Hi, in this session let us discuss about the two-way and three-way control of lamps, the working and also the different protective devices. Let us first consider the two-way and the three-way control of lamps. So in domestic lighting circuits where they are quite simple and usually controlled from one point. But in certain cases, it may be necessary to control the single lamp from more than one point. Especially in staircases or long corridors, large halls, etc. In such places, we will prefer to use the two-way control of lamp or the three-way control of lamp. So first, let us consider the two-way control of lamp. The two-way control is generally used for the staircase lighting purpose. The lamp can be controlled from two different points. So one at top and the other at the bottom using two-way switches. So which are interconnected by the strap wires. So they are also used in bedrooms or in big halls or in large corridors. So this is what the circuit for two-way control of lamp looks like. Here it contains two switches, S1 and then S2. The position of the switches are 1, 2, 3 and 4. And now this table will indicate the working of this two-way control of lamp circuit. Okay, so let us see how it exactly works and under which condition the bulb will glow and under which condition it will be off. Okay, switch S1 considering in position 1 and switch S2 in position 3. So here from 1 and then 3. So there is a closed path here for the current to flow and the lamp will be on. Okay, now let us keep the position of S1 at 1, but let us change the position of S2 to 4. Okay, so what happens here is, so think that this will comes to this position and here S1 is pointing to 1. So we can see that this neutral point will be connected to this like this, and here there is an open at switch 1. Therefore, the current will not flow and the lamp will be off. And the third condition, let us have the position of switch S1 at 2 and position of switch S2 at 3. So if it is at this point, S1 is at 2 and S2 is at 3, again there is an open path, current will not flow and the bulb will be off. And the last condition, let us bring the position of S1 at 2 and S2 at 4, there is a closed path, the current will flow and the bulb will on. Okay, now we'll consider the another type, that is a three-way control of lamp. So this is what the arrangement for the three-way control of lamp looks like. Here we have used three switches, S1, S3 and then S2. So S3 we call it as an intermediate switch. Basically it operates in two modes, the straight mode and then cross connect mode. Straight mode and then cross connection mode. So straight mode in the sense the position of S3 will be at from A to B and C to D. In cross connect mode, the S3 position will be from A to D and B to C. Okay, now by keeping the position of S3 in straight mode and by changing the position of S1 and S2 at different points, that is 1, 2, 3 and 4, So let us observe how the circuit behaves, and similarly for the cross connect mode. So we'll consider first the straight mode. Straight mode meaning the S3 will be establishing the connection between A to B and C to D. Okay, and now assume the position of S1 is at 1 and S2 is at 3. So this point will be 3 to B, B to A to 1, and it will be closed path. The current will flow, the lamp will be glow. It will be on. Okay. Next, consider the second position. Having the S3 in the straight connection mode, we'll keep S1 at 1 itself, and S3 we will bring it to 4. So when we bring it to 4, so this wire will be given to 4, D, C and then 2. But S1 is actually pointing at 1. There is an open path and the lamp will be off because the current will not flow. Now we will keep S2 at 4 itself and bringing the S1 to 2. So here this wire will be given to 4, D, C, 2 and it is a closed path. The lamp will be glowing because the current flows. Okay, so these are the different status when the intermediate switch S3 is in the straight mode. And now let us see that when it is having the cross connection mode, or when the S3 establishes the connection between A to D and B to C. Now we will keep the position of S1 at 1 and S2 at 3. Now we'll see what happens. So S1 will be given to 1, 1 to A to D and D to 4. But actually S2 we are pointing to 3. So there is an open path here. The bulb should be off. So which we have mentioned in this first case, 1, 3 and it is off. Now we will consider the second case, 1 and 4. S1 at 1, S2 at 4 and S3 in the cross mode. So just observe, S1 will be pointing to 1, 1 to A to D, D to 4. So S2 we are pointing, if we point it to 4, there is a closed path, the lamp should be glowing, it is on. Okay, so this is how the two-way and three-way control of lamp can be controlled from 2 places and from the 3 places, and we can make use it most commonly in the staircase applications, large corridors, and even in bedrooms or for the large halls, etc. Okay, now let us move to the next topic, that is the different protective devices. Okay, so these are the few protecting devices: fuses, miniature circuit breaker, earth leakage circuit breaker, residual current circuit breaker. So why we need these protective devices first of all? So sometimes we may observe that there will be a flow of high current due to the short circuit. In such cases, it may damage the electric appliances which we use in the house or in offices. Hence, in order to protect those electric appliances from getting damaged due to such a flow of large amount of currents due to the short circuit, we will be preferring the protective devices. First, let us consider the fuse. Fuse is a safety device. It is generally a weak link which is connected in series with the circuit. Whenever there is a flow of large current, the material will get melts, and it disconnects the circuit and avoids the flow of excess current, and hence it gives a protection to the appliances which is connected to the load. So this is what this is how the fuse looks like. Okay, so fuse generally contains the metal strip or a wire fuse element of small cross section compared to the circuit conductors, which is mounted between the pair of electrical terminals enclosed by a non-combustible housing. Generally, as I said, fuse is connected in series in the circuit, in the protected circuit. The resistance of the element generates the heat due to which the current flows. The size and construction of the element is determined so that the heat produced for the normal current doesn't causes the element to attain the high temperature. If it is too high that the current flows, then the element raises to the higher temperature, either directly melts or melts a soldered joint within the fuse, and it opens the circuit. Let us discuss few important definitions related to the fuse, different parameters. First one is fuse element. So the part of the fuse which melts when the excess current flows through it, we call it as fuse element or fuse wire. The part of the element which melts when the excess current flows, we call it as fuse element or the fuse wire. Next is fusing current. The minimum value of the current at which the fuse element melts to interrupt the circuit current is known as a fusing current. So fusing current in the sense, this is the minimum current at which the fuse element melts. Fusing factor. So it is nothing but the ratio of minimum fusing current and the current rating of the fuse. Fusing factor is equal to minimum fusing current divided by current rating of the fuse. Next one is rated current of the fuse. So this is the maximum current which the fusing element can normally carry without any overheating or without melting. So that means the maximum current at which the fuse can carry without getting overheated or without melting. So generally the rated current depends on the temperature raise of the fuse contact of the fuse holder or the fusing element material that we choose, deterioration of the fuse to oxidation. So based on these parameters, the rated current, these are the parameters on which the rated current of the fuse depends. Next one is miniature circuit breaker. This is another protective device. Okay, so whenever there is a flow of high current, then the MCB will trips off and it opens the circuit, and hence it protects the appliances which are being connected, and hence it gives the protection. So generally the MCBs will trips within 2.5 milliseconds when there is a flow of excess current. In case of temperature rise or overheating, then it may take 2 seconds to 2 minutes for the MCB to trip. So this is what the structure, internal structure of the MCB looks like. Next is earth leakage circuit breaker. So a device which can directly detect the earth leakage current and cuts the supply if such current exceeds the present value. So such a devices are called as an earth leakage circuit breaker. The device which can detect the earth leakage current and cuts the supply if such current exceeds the present value. So we call them as ELCB or earth leakage circuit breaker. The voltage operate ELCB, it contains a relay coil or an ELCB coil. So ELCB, generally it contains a relay coil or the ELCB coil. So you can observe here the one end of the ELCB coil is connected to the load and other end is connected to the earth wire. Okay. One end is connected to the load and the other end is connected to the earth wire here. So when the voltage of the load raises, there will be a difference in voltage between the load and an earth wire, which results in an electric shock. So this potential or the voltage difference may cause the current to flow from load to the ground through the relay coil loop. So here. So generally when there is a voltage difference which is greater than 50 volts, current through the loop will move the relay and hence it disconnects the supply. The voltage operate ELCB detects only the electric fault from the phase to the earth wire within the load it protects. So it cannot detect the fault currents that flows between phase and any other earth. So it can detect only the electric fault from phase to the earth wire within the load it protects. So in other cases the ELCB cannot protect against the electric shock. So the last one is RCCB, that is residual current circuit breaker. So the current operated ELCBs are generally known as residual current devices. These also protects against the earth leakage. So both the circuit conductors, that is supply and return, are run through a sensing coil. So any imbalance of the current happens, then the magnetic field does not perfectly cancel. The device which can detect the imbalance is RCCB and it trips the contact. So this is what the arrangement for RCCB looks like. In a healthy circuit, the same current will be passing through the phase coil, the load and the return back through the neutral coil. Both the phase and neutral coils will be wounded in such a way that they can produce the opposing magnetic flux. So with the same current passing through both the coils, their magnetic effect get cancels out because the magnetic field will be in an opposite direction. Hence the magnetic effect will get cancels out under an healthy circuit condition. But in a situation that whenever there is a fault or a leakage to the earth in a load circuit or anywhere between load circuit and the output connection of the RCB circuit, the current which returns through the neutral coil will be reduced. Then the magnetic flux inside the transformer core will not balance anymore. So the total sum of opposing magnetic flux will no longer be 0. This net whatever the remaining flux is nothing but called as a residual flux. Okay. The periodically changing residual flux inside the transformer core will crosses the path with the winding of the such coil. This action will produces the electromotive force across the such coil. So this EMF is generally an we call it as an alternating voltage, generally an alternating in nature, and the induced voltage across the such coil will produces the current inside wiring of the trip circuit. So it is this current which operates the trip coil of the circuit breaker. Since the trip current is driven by the residual magnetic flux, that is the resulting flux, the net effect between both the fluxes, the phase and the neutral coil, we call it as a residual current device with the circuit breaker which is incorporated as part of the circuit. And this assembled system is known as an RCCB or residual current circuit breaker. So the incoming current has to pass through the circuit breaker first before going to the phase lines. That's all. Thank you.